Solving a rational inequality means that you also have to use the sign chart, but you have to do so when the denominator equals 0 as well, which means that the overall function would be undefined. So to do these types of problems, I'm going to look at two different ones. The first one is going to be where you have to set it equal to greater than 0. And so when you do this, you're going to see that you have x minus 1 over x plus 2. And then when I subtract 3 off both sides, I want to also have the same denominator of x plus 2. So a couple things at once here. This is going to be 3x plus 6, which is now greater than 0. That means that it's going to be a minus 2x minus 7 over x plus 2 greater than 0. That means that when you draw that number line, what you're going to see is a couple different places. One, where 2x minus 7 is equal to 0, and when you solve for that, you're going to have a negative 7 halves, which is 3.5, and negative 2. So this is negative 3.5 and negative 2, and the question is what happens when you plug in numbers. If you put in negative 4, you're going to have a positive 8, which becomes positive over negative. That gets a little bit tricky there, so be careful. Negative 3, which would be a positive 6, would be a negative over a negative, which becomes now a positive. And if you plugged in 0, for example, you'd have negative 7 halves, which means that this is going to be negative. Therefore, your answers on this one, where it's greater than 3, are going to be right between these two, which means that it's from not including negative 3.5 to negative 2, not including negative 2. Looking at problem number 3, we have to be able to add those two fractions on the left side. And when we add those two fractions, what we're going to do is get common denominators. So I'm going to multiply the left side by x minus 4 over x minus 4, and the right side by x plus 2 over x plus 2. When you do so, you get the following. X minus 4 over x plus 2 times x minus 4. And then on the right side, it would be the same denominator, so I'm just going to make one big fraction here, and it's going to be plus 3x plus 6 by multiplying top bound by x plus 2, greater than 0. Combining terms, 4x minus plus 2 over x plus 2, x minus 4. And therefore, you're going to have your points on the number line again. All zeros and undefined, numbers that make undefined f of x's is what you're trying to test. So again, looking at this, I'm going to have a negative 2. The 0 is going to be at negative 1/2. And the other point that makes this undefined is going to be at 4. Now, notice that I did this in order, and I did in my head, so I'm saving some steps as I go along. Now you have to test the top and the bottom to see if it's positive or negative. So negative 3, that's going to yield a negative on top over negative times a negative. That means that's going to all equal a negative. Between here, negative 1, again, negative on top. When you substitute in, negative 1 is going to be a positive, and the next one is going to be a negative. So that makes a positive. Don't assume it's always going to alternate pluses and negatives. You have to test each case. This is going to be easiest one, 0, so it's going to be a positive over positive and negative. That's going to mean that this is going to be a negative, and a 5 would yield a positive, positive, and positive, which makes it positive. In this particular case, you can see where it's going to be greater than 0. You're looking at this one and this region. Therefore, the way to write this would be, again, an interval notation where you have a union case. All real numbers between -2 and -1/2, or all real numbers greater than 4. Make sure you check all your zeros and all your x's that make undefined functions in the number line.